Hello, so we're back, and this time we have a customer job. This is a nice laptop. It's a nice HP laptop, i3 CPU. And what the customer is saying, that's what the customer writes, not charging on this battery as battery is flat. Charger working perfectly. Laptop works fine on charged battery, but is not receiving charge. Power jack working perfect. Laptop not updated for a long time, but battery replacement too low percentage to update. So what do we know about this laptop? We know if the customer is swapping the battery with a charged one, the laptop is working. But if he's plugging the charger, it's not charging. So this it will be an interesting job. I mean, the customer is saying the power jack working perfect means we can have a motherboard fault. Now pressing the power button and it's not coming on, it's not doing anything. Let's open quickly the laptop and have a look inside. Okay, and the laptop is open. So okay, we have a standard blue pin HP charger. Let's plug the charger and see what's happened. So I have my charger, which is connected to the power supply. And now we need the blue pin, the HP blue pin, which is this one. Now let's switch the power supply to 19 volts. Some amps, not too much. Plug in the charger, and it's doing nothing. It's taking no current. Pressing the power button, nothing. It's taking no current, nothing. Okay, so what we are checking first? I mean, first to check probably is to see if we have power on the charging port, right? On the charging port connector. So the charging port is coming here. A multimeter, ground. We are not taking ground from here. You can see we have black, red, and white. White is the charger ID pin. So ground from here and plus here. And we do have, yeah, the customer is right. Check that, 19.4 volts. So the customer is right. The charging port can be good. Can be. The data line. Data line had like 0.5 volts, can be good. Okay, so do you think this will be a complicated job? I mean, what we are checking first? The main power rail, right? The main power rail is 19 volts. Check on the screen, 19 volts. You see, the main power rail is present. So why the laptop is not working? Well, it will be a good question. Battery voltage, 0. 0. 0. Okay, so why the main power rail is not present on those power supply? You can see them, yeah? And here coil, you have the driver here, which is switching the coil. And here you have the input capacitors, yeah? Here you have 0 volts. And here we have 0 volts. So why do we have 0 volts, but not here? Not on this one. On this one we have, this one we have 0, okay? So we have 0. But on this one we have 0. Okay, so where do we have 19? Wait, I'm confused. Now here you have 0. Here we have 0. So how this is possible? And my multimeter is broken or what? So here you have 0. I see 19, right? Yeah, check the 19. Okay, why do we have here 19 and only here? You see, this design is same like the MacBook. You have a main power rail, or a main power supply, sorry, which is feeding the whole laptop, yeah? So the main power rail from the laptop is created by this coil. And you have two MOSFETs on one side and you have two MOSFETs on the other side, which is, and this is the bridge configuration, and the coil is switched by those four MOSFETs. Same like on the MacBooks. So the problem on this case is uh, here on this power supply, this is a power supply, we have 19.4. But anywhere else, we have 0 because this power supply is not outputting anything. So we're gonna focus on this power supply to see which chip is switching this power supply and try to restore the main power rail. The main power rail in this case is the battery voltage. So the battery has like 11.5, so the main power rail should be around 12 volts. Let's check that one. Okay, so now here we can clearly see. So this is the high side MOSFET and we have 19. Then here we have the low side MOSFET connected to ground and coil here, and then the other two MOSFETs. And from here I should have my main power rail, which is 0 volts. Okay, and also 0 on the coil. So those MOSFETs are not switching. Now we have to find the driver from for these two MOSFETs. Probably it's on the other side of the board, so I have to take the board out and have a look on the other side. Okay, so we took the motherboard out. Let's see. So on the other side of the coil and the MOSFETs, we have a chip. You can see it. Let's check what chip it is. Intersil 9538CH. Yeah, this is an interesting chip. Let me plug the charger and let's check if we have any input voltage. So I plug the charger, and what do we have here? Here we have nothing. Here we have nothing. Here we have nothing. And here we have 0.7. Here we have 19, lol. So we do have 19. Okay, that sucks. Yeah, probably the chip is gone, but before replacing the chip, let's check the MOSFETs to be sure the MOSFETs are good. So the MOSFETs are good. So this one is good. This one is good. Good. And good. Okay, let's find the chip datasheet. Okay, I found it. So check here. Yeah. So this is our schematic. So we have 4 MOSFETs to here with the coil in the middle. So what we are looking for, basically, we are looking for charger detect and the chip enable DC, and this is present. I mean, kind of pointless because probably the chip is dead, you know what I mean? It's not much what we can check here. Okay. Let's see. So what do we need? It's ADPS. ADPS, which is on the pin number. ADPS. So ADPS is where? ADPS, pin number 13. Yeah, let's check the voltage on that pin. So pin number 13 is here. And we have 18.6, you can see on the screen. Yeah. So I will say let's go forward and replace this chip because I believe it's dead. Okay, so let's replace the chip quickly. A little bit of flux. So the chip is out. The chip position, okay. And we have this one. Good. We need a little bit of flux. Perfect. Now the question is, it will work or not? That's the question. And I believe yes, I believe it will work. I mean, I know the board looks so complicated, you can actually believe can be anything. But not so much, you know. The random, resistors, capacitor, they will not get burned. Usually the chip, it will get burned. Okay, so we cool down the chip. Let's plug the charger. Let's see. So if we are plugging the charger, do we have our main power rail? No, it's taking no current. Lol. 0 volts. So we replace that chip for nothing. Okay. So what do we know? What do we know about this chip? We know nothing. But in order this chip to work and switch those things, the chip has to speak with the IO chip. Okay? So I will say let's jump to the IO chip and see if the IO chip has 3.3, which I really doubted. One second, let me connect the battery. Let's bring some voltage onto the battery. I believe this board, it will not work if it doesn't have the battery attached. And the battery is not charging at all. So to charge the battery, we need ground and we need plus here. And it's taking like 30 milliamps. And now it's taking 1.4 amps. So we are charging the battery right now. Let me switch to 19 and see if the board is charging. No, it's still not charging. Let's see what voltage do we have on the battery. So on the battery we have nothing, 0. Okay, 0 on the battery is not good. 1 amp. We are charging the battery with 1 amp. Okay, so on this point, we are focusing on the battery. So the battery has 0 volts on the output, right? Yeah, 0, nothing. The battery is taking current, yes. So coming with a plus on the battery, check there on the ammeter, 3 amps, I set up the current 3 amps, then it's going to 0. That means the battery has voltage, but it's not outputting anything, yeah? What does it mean? If it's not outputting voltage, means the battery has a problem. Now, the main problem is this chip, which is creating the main power rail. So what will be the voltage of the main power rail? Will be the battery voltage. So how this chip it will know to create the battery voltage? How this chip it will know? It will read the battery, yeah, through the data lines. And if the battery has an issue, it will not start this power supply. So let's take the NLBA adapter and let's try to find a problem with this battery, because I believe this battery is locked. Yeah, I mean, we have no output on this battery. I mean, if I check with the multimeter, right? So checking with the multimeter, we have plus, we have minus, 0 volts, right? Yeah, yeah. So let's get the NLBA device and try quickly to figure it out what's the issue with this battery. Okay, so the battery is looking good. It is on lock, but has a poor balance and is very discharged. But the battery, it is good. Now let's charge the battery a little bit. Okay, so we left the battery on charge for a bit. Stop charging. Let's see again. Yeah, now the cells are fine. Yeah, balance, it's unlocked. They have like 3.7 volts. The battery health is very good. I think it's the moment, to go back and try to figure out what's wrong with this laptop. Now let's plug the battery back to the motherboard and see if we have any voltage. So the battery is plugged in. And we have 11.1 volts, but why you can't see? Yeah. So we have 11.1, you can see. Hopefully the board is not coming on. So the main power rail now must be present. It is 11.1. Let's plug the charger. So plug in the charger. And it's still not working. It's not taking any power. Like nothing. Like the charger is not even plugged in. Nothing. And here we have the battery voltage, right? No. 1 second. Why we don't have here the battery voltage? So here we have 19, right? Yeah, we have 19. But here is supposed to have the battery voltage, or here. Yeah, here. Here you have the battery voltage. Lol. Nothing. It's like this is dead, like completely dead. This power supply is dead. The EC chip, something is wrong here. And, the EC chip have nothing. 3.2. Okay, so now we have voltage on the AC chip. BIOS chip, we have nothing. You know what? I'm still back to square one. I mean, I still have no idea what's the issue with this board. What I know, my chip is not working. The chip providing the main power rail. And the thing is, it's nothing what you can check. I mean, this chip is speaking based on data and clock and data with the AC chip and with the battery probably. 1 second, let's check these pins. Yeah, 1 second, 1 second. I want to check this pin. CS in and CS IP. CS in and CS IP. Pin number 14 and 15. So pin number 14 and 15, we should have very low resistance there. So will be this. And we have like 4 ohms, which is right. Let me plug the charger without the battery. Good. So here is 19, here is 19. Okay, pin number 13. Let's go back to pin number 13. Why do we have 18.5 volts there? I mean, according with the chip schematic, yeah, pin number 13, ADPS, yeah. I mean, okay, I got it. That pin has to identify the input voltage, yeah. So basically, it's enabling the chip. But we have a divider. I mean, what kind of divider can be here to have like 18 volts? I mean, what's the point to have a divider then? On the BQ chips, you have like 2.5 volts after this divider. But here you have like 18. Can be right? Let's see where this pin is going. And pin number 1 and pin number 2, 1 second. Pin number 1 and pin number 2. 3 ohms. So this has 2.5 and 2.5 on a total of 4.8. And pin number 13 probably is going on the other side of the board. I believe this is the divider we are looking for. I believe this is the one. So we have 2.8. Wait, what? So here you have 19, here you have 2.8, right? So why do we have on the pin of the chip like 25, huh? Like, sorry, 28. What is it? Why on this pin we have 18.5? Huh? It doesn't make sense. 1 second. So according with the chip data sheet, yeah, pin number 13, ADPS. ADPS, revert output voltage feedback. Use a resistor divider to configure the reverse output voltage. Okay, so what has to be that voltage? I said is the pin. ADP, ADPS, ADP. Which one is ADP? ADP. What is this, ADP? What pin is that? ADP, pin number 16. So ADP is 19. Okay, so it's present. Wait, you know what? I'm still confused and I'm not happy with that. Why on the ADPS, okay, we have 18 volts, and on this divider, from here we have 2.5. I mean, what's the catch? What we are doing wrong? Where this pin is going? We have no idea where this pin is going, the pin number 30. That's my problem, that's my issue. Where that pin is going? Okay, you know what? Let's take the chip out because I'm not in clear. Good. So the chip is out. I'll plug the charger. Let's check that pin again. This pin. And we have no voltage, lol. So check here on the pin number 13, we have nothing. Nothing. Like literally nothing. We have no voltage. So how that is possible? I mean, the 19, it is present, right? I mean, you can check anywhere. Like here, 19, yeah? But here you have nothing. Okay, so, and this is the input divider. Pin number 13 is this one. ADPS, and ADPS has to be connected to a divider. You see input divider, you have from 19, you have a divider, and yeah. So what's the catch? Why we have no voltage? The problem is without a board view, it sucks. Because I try to find with the beeping and I cannot find that truck where it's going. It's going somewhere inside of the board. But where it's going, I have no idea. So this is unconnected. Now, I'm just guessing that truck, yeah, but this is just a guess. That truck is going here. So here I have 2.5 volts. This is a divider, you can see. It's a divider and it's coming here. And it's going somewhere. We have no idea where. So what we are doing, I wish I can know. But let's take a wire from that divider and bring, like, manually solder a wire to this chip. Let me solder the chip back. Okay, I'll solder back the original chip. So you understand how confusing it is? You check the pin, and we check the pin, and the pin has like 18.5, which probably is the voltage because the pin is not connecting anywhere, so the voltage is coming from the chip. And you believe, no, it's the input voltage. That's what you all believe, exactly like I believe. I believe, you know what? No, that voltage comes from the input, but it doesn't. So let me cool down the chip. Let's connect the charger and check one more time that pin. So I plug the charger. Now let's come with the multimeter. So one more time, yeah? This pin, 18.5, you can see on the screen. And you think, sorry, this voltage comes from the charger, but it doesn't. This voltage comes from inside of the chip because the pin is in air. It's not connecting anywhere. It's not connected. So what I'm gonna do, I can do a divider here with two resistors. That's something that what I can do, but will be dodgy, yeah? I mean, let's use a wire from the pin number 13. Let's use a wire from there to that divider, which I seen it there. I will need some rosin. You see, this was a tricky job. I mean, we are like over 1 hour of recording. You can believe that? And yeah, I did assume, yeah, probably the chip is dead because you will think can be like a missing track. The track is missing. That's our issue. Good. So the thing is solder. Let me use a little bit of hot glue to just, hold the pin in place, hold the wire in place. Perfect. So where we are going with this wire? We are going here. To this divider. Because I believe this was, the original track coming here. Bore view, it will be helpful, but we don't have something like that. Oh, come on. Come on. Don't do something like that. Yeah, perfect. Okay. So we solder the wire. Good. So what about now? Now it's time for testing. Let's plug the charger. Nothing. I mean, it's not working. That's crazy. I mean, how? We fixed the problem with the divider, right? And now on the divider we have 7.3 volts. I don't think it has to be 7, well, yeah, maybe. Let's plug the battery. Nothing. Okay, let's see. Let's see some things here. Yeah. Okay, this is doing a buck and boost. Yeah, on the same time. So probably has a USB-C. Yeah, has a USB-C, and can also boost the voltage based on the ADP pin. Soft start. Okay. When VDD. Okay. Okay, this is nice. So the chip is working up to 26.4 volts. That's a 5 volts LDO. I didn't see that. Output of the VDD pin. Under 50 milliamps. Wait, did you see any 5 volts there? VDD, where is this VDD pin? At the VDD pin. Let's check that pin. 1 second. Where is the VDD pin? VDD is pin number 18. Let's see. Pin number 18. So pin number 18. We have 1.8 volts. Why? We should have 5 volts, right? So here, now it's 3.7. $1.6. Wait, this track is not coming here? No, it's not. It's coming here. So here you have 1.8. 1.8 volts. Wait, why do we have 1.8 volts on a pin which is supposed to have 5 volts? Where is the schematic? VDD, VDDP. internal LDO output. Provide the bias power, blah, blah, blah. And VDDP, what is VDDP? I mean, I should have like 165 milliamps max on this pin. Wait, that's strange. Yeah, let's remove my wire. Clearly, that's not our problem. No idea where this is going, but yeah. One second, because this is interesting, you know. I mean, there should be 5 volts. LDO, right? Okay, let's come with the power supply with 5 volts and let's see what's happened. 5 volts, low current. And it's taking no power. Like nothing. Yeah, the power supply is good. So here is taking no power at all. So I don't understand why the chip is missing the 5 volts. Why my board is taking 10 milliamps? Why my board is working now? Huh? Anyone knows? So now my board is taking 20 milliamps, 10 milliamps, which is right. Yeah, why the board is doing something like that? I done nothing and my board started working, right? No, we have light here. Check here. You can see the light? Basically, we done nothing apart from coming with a power supply with 5 volts on that pin. And now the LED is on. And the main power rail is 13.2. Just tell me I did something. Nothing. And on that pin, which we were looking for, yeah, the one with the 5 volts. Yeah, probably is that capacitor, right? Probably. So now if I check the voltage there, yeah? I mean, we done nothing. We done absolutely nothing. So on that pin, this one, we have 5.1. And here we have 5.1, and I have no idea where this track is going. You know what? That sucks. That sucks. Basically, we done nothing, just spinning around on over 1 hour on this board, and the board start working like, you know, like nothing happened. Like, okay, yeah, now I'm working. So, and it's charging fine, check there. So we plug the charger and it's taking like 180 milliamps. And probably the current will goes up. Yeah, it's going up. Oh, sorry, we don't have current. Wait. 180 milliamps, you can see there. 2.6 amps. So you see, this is like, this is that kind of job you always try to avoid. You always, I mean, it's nothing faulty and it's nothing good. I mean, what we did, nothing, like that, literally nothing. This is the original chip which came with the board. Nothing. How can I post on YouTube a video which has like 1 hour and a half right now? Yeah. So this video, check here on the bottom, yeah, 1 hour and a half. How can I post a video about doing nothing to fix a motherboard? So the main power rail is 12.8, which is the battery voltage. Don't laugh. This is good. It's only 1 hour and a half. But I have jobs I spend like 2-3 hours, and suddenly start everything working fine, no issues whatsoever. So what I should fix now? Just tell me what I should fix now. What I should fix? Change that capacitor. I will do it just to be sure this job it will not come back. But I believe I unlock that, or I remove whatever short was there on that pin, on the 5 volts pin. I remove it when I came with the power supply, and most likely that capacitor, because I had that resistor and a capacitor on that power rail. And now it's working fine, charging fine, 2.7 amps. Yeah. Okay, let's replace that capacitor quickly. I mean, otherwise we are risking, we are sending back the laptop, and at some point the laptop, it will die. Yeah, this one. So I suspect this was the issue, the capacitor. It's a bigger one, yeah, it is. Bigger is better when it's about capacitors, right? Must be. Perfect. Okay, so we solder the capacitor. I mean, what did I did wrong? This is Sunday. We had in the morning that nice coffee live stream, yeah? And I said, you know what? Let me start a easy job. I mean, when I seen the job, it's just an HP laptop, a simple HP laptop. What can be complicated there? And it's turning out to be like a mad, insane kind of job, where actually nothing is faulty, but also nothing is good. Crazy. So now plug in the battery, plug in the charger, and everything is fine. Let's wait for the switch for the charging current. Yeah, 2.6 amp charging current. Okay, let's put the board back quickly. Okay, everything is on place. Plug in the charger and it's charging fine. Good, so pressing the power button. Yeah, we do have the charging light. Where is the power button? Where is the power button on this one? Oh, it's this one. So pressing the power button and it is coming on. Yeah, it's taking like 2 amps, 2.2. Yeah, we reached the bias, so we have to wait a little bit. The fan is spinning. And yeah, we have picture. Yeah, obviously it's no hard drive there. But we have picture. But that's not the issue because the laptop was working before, right? The problem was not charging. And yeah, that was the issue, not charging. So I switched the laptop off and the laptop is still charging fine. And also we have the orange light there. Not sure if you can see it. It's the orange light there. Okay, so I'll stop now because this was 1 hour and 40 minutes. I can't believe. You know, I'm pretty sure I'm not the only one. I mean, you can laugh. It's okay. I can understand that. I mean, I'm laughing. You know what I mean? But I'm pretty sure I'm not the only one. I am not the only one. Like spinning around like for a long time, finding actually nothing. Okay? So I'll say thank you for watching. Like and subscribe if you like the video, and see you on the next one. Bye.